Okay, so today we're going to look at Gaussian-Jordan elimination. And what this is the use of elementary row operations to solve a system of equations. So the first thing we need to do is we need to transform our system of equations into an augmented matrix. So anytime we're missing a variable, we're going to put a 0 in. So then -3 for my coefficient for B, 1 for my coefficient for C, 15. -2, 3, 2, 11, -3, -4, 1, 30. So there's my augmented system. Now, remember our elementary row operations were row switching, row addition, and row multiplication. The first thing I'm going to do is I'm going to switch row 1 and row 2. So I'm going to rewrite my matrix with those two rows switched. So -2, 3, 2, 11, 0, -3, 1, 15, -3, -4, 1, 30. And the reason I did this is for Gaussian-Jordan elimination, we want to get a 0 into the first position of the second row. We do not want a 0 in the first position of the first row. So swapping these two allows me to get that 0 into that first position of the second row. Now, for my next step, I need to get a 0 in this first position of my third row. So I'm going to take my first row and I'm going to add it to my third row. But because they're different coefficients and they're the same sign, I need to multiply both of them by something. So I'm going to multiply row 1 by +3. Then I'm going to add it to row 2 multiplied by a -2. And if I do the math for this, row 1 is going to become -6, 9, 6, 33. And row 3 is going to become +6, +8, -2, -60. And when I add those together, I get 0, 17, 4, -27. So rewriting my matrix, -2, 3, 2, 11, 0, -3, 1, 15, 0, 17, 4, -27. Now, I've got a 0 in my first position of my second row and a 0 in the first position of my third row. I need now to get a 0 in this second position of my third row. And unfortunately, 3 and 17 are primes, so the least common multiple of them is the two multiplied together. But they're both opposite signs already, so I'm just going to multiply by the positives of each other. So I'm going to take 17 row 2 plus 3 row 3, and I'm going to put that into row 3. So 17 times row 2 is 0, -51, 17, 225. And then 3 times row 3, 0, 51, 12, -81. Add these together, and I get 0, 0, 19, 174, 29, and 174. So I can rewrite my matrix. -2, 3, 2, 11, 0, -3, 1, 15, 0, 0, 29, 174. Now, we are in echelon form. We haven't reduced the rows yet, but we have a single variable here. So if we go back and we look at how our equations are written, this last row 3 could be written as 29C equals 174. Divide both sides by 29. And we get C equals positive 6. Now that I have this C as a positive 6, I can go to row 2 and write that equation. So it's negative 3b plus 1c, and we know c is 6, equals 15. So negative 3b equals 9, b equals negative 3. Now, last step. I can take my 6 for c and my negative 3 for b, and I can go back to my first equation. And I have negative 2a plus 3 times negative 3, negative 9, plus 2 times 6 plus 12 equals 11. These two together, I've got negative 2a plus 3 equals 11. Negative 2a equals 8, or a equals negative 4. So now I have my 3 variables that satisfy my system of equations, and I can write my ordered triple as negative 4, negative 3, 6. Okay, so to break down Gaussian-Jordan elimination by steps, step 1, we're going to create our augmented matrix. Step 2, we're going to row switch as necessary. Again, just to rearrange if we need to, if there's any of the equations that are more suitable in another location. So then our first major step, row 3, we're going to add row 1 plus row 2 and put it into row 2, doing any multiplication necessary to get where our first variable is going to cancel out, to cancel first variable. Then we're going to add row 1 plus row 3, put that into row 3 to do the same thing, to cancel that first variable. Step 5, we're going to add row 2 to row 3 and place that into row 3 to cancel the second variable. Again, doing any multiplication that we need to do in order to get the same coefficient opposite sides. Once we've done this, we can now solve for our third variable. And then 7, reverse substitute to find our other 2. Into second equation. And then do the same, reverse substitute into first equation. Find our last variable. Then we can write our ordered triple. And then we could validate by substituting the values into the original equations. And that's it.